This is Odum Maths. Today I want us to look at exponential equation. But before we look at exponential equation, let's use some 1 minute to look at zero index. Zero index, that is variables or numbers having a power to be zero. So before we look at zero index, let's remind ourselves on the second law of indices, which states that a is having a power m being divided by a with a power n, and that becomes a equal to the power m minus n. That is when they are dividing, when two numbers are divided and they are of the same base with different powers, what you do is you just subtract powers. Okay, so let's say we have a with a power 2 divided by another a with a power 2. So this becomes a to the power 2 minus 2. Okay, and subsequently this is going to be a to the power 0. Okay, now let's rewrite this in another form. So I can say a to the power 2 divided by a to the power 2 is the same as a times a over a times a. So this is going to be, this into itself 1, here 1. This into itself 1, here 1. So we have 1 times 1, which is 1. Then 1 times 1 again, which is also 1. And that is going to be 1. So it means that any number to the power 0 is 1. So therefore, a having a power 0 is equal to 1. Because the same a to the power 2 divided by a to the power 2 gave us a to the power 0. And the same a to the power 2 divided by a to the power 2 also gave us 1. So therefore, a to the power 0 is equal to 1. So here, where a is any number, okay, so a can be any number. So any number raised to the power 0 is 1. Okay, now let's proceed to look at our equation involving indices or exponential equation. Okay, once more, I want you to try this. So negative into brackets half to the power 12 times half to the power negative 20 times 1 over 8 all over 1 over 2 to the power 5, negative 5 times 1 over 2 to the power 3. So please try it and then let me see your answer in the comment section. Now let's talk about exponential equation. Exponential equation. So let's say we have variable b with a power x that is equal to another variable b with a power y. Now since the bases are the same, so we just equate the powers. So therefore x is equal to y. Okay, so since the bases are the same, we just equate powers. So therefore x is equal to y. Okay, now let's look at this. 3 to the power x equals 3. So this 3 is having a power 1. So we say since the bases are the same, therefore x is equal to 1. Okay, let's take one more example. Let's say we have 3 to the power x equals 9. Okay, now with this we can rewrite this as being 3 to the power 2 because 3 to the power 2 is 9 and then 3 to the power x. So therefore, since the bases are the same, x is equal to 2. Okay, let's continue with more examples. Now let's look at this. So we are given to find x, 16 to the power x equals 8. Okay, now let's ask ourselves, which of the prime numbers can we write as a base with a certain power which will be equal to 16? 2 will do. So here, 2 to the power 4 is the same as 16 and our x is also here. And that is equal to, this can also be 2 to the power 3. Okay, so the third law says that when this is happening, we multiply powers. So that is going to be 2 to the power 4x equals 2 to the power 3. Now the bases are the same, so we just equate powers. So 4x becomes 3. Then we divide both sides by 4, and then x becomes 3 over 4. Okay, so after you can substitute this into this to see whether that is going to give you 8. Okay, now let's look at one more example. Okay, so with this also, we are given to find x if 9 to the power 4x is equal to 81. So this is 9 to the power 4x, and we can rewrite this as 9 to the power 2. Or somebody can also say, okay, why don't I change this to 3 to the power 2 and then this is 3 to the power 4, and you all get the same answer. But with this, let's use the 9. Okay, now looking at this one, the base are the same, so 4x becomes 2. Then we divide both sides by 4. So x is going to be 1 over 2. Well, that is 2 cancels itself 1 and cancels here 2. So 1 over 2. Okay, let's take another example. Let's again look at this example. So this is 4 to the power negative 3x equals 1 over 64. And we can write 64 as 4 to the power 3. 64 is the same as 4 to the power 3. So we can change this to 4 to the negative 3x equals 64 to the negative 1. That is 1 over 64 is the same as this one. Okay. Then 4 to the negative 3x becomes, now 64 is now 4 to the power 3. All to the power negative 1. So then 4 to the power negative 3x becomes, now this is the third law. So we just need to multiply powers. So that is 4 to the power negative 3. Then since the base are the same, so we just equate the powers. So this is negative 3x equals negative 3. Then we divide both sides by negative 3 to get x. So x is 1. Okay. So that is that. Let's go look for another example. Okay, let's look at one more example. So 16 to the power x equals 0.125. Okay. Now, what is 0.125? 0.125 is the same as 1 over 8. So when you put this on the calculator, then you press SD on the calculator. S, then something like this, D. It's on the calculator. Okay. So when you put this symbol on the calculator, it will change it to either this or the maybe decimals. So put this one on the calculator, press SD, you get this. Now this is 0.125. So this is 16 to the power x. Now we can put 16 to the power this as 8 to the negative 1. Okay. Then again, let's change the bases to a certain base with a certain power that will give you the same base. Okay. So this is 2 to the power 4 all to the power x. Then this is equal to 2 to the power 3 also to the power negative 1. Okay. Then from here, the third law, so we just multiply powers. So this is 2 to the power 4x. That is equal to 2 to the power negative 3. Then the bases are now the same. So we just equate powers. So 4x becomes negative 3. Then we divide this side by 4 to get x being equal to negative 3 over 4. Okay, let's look at another example. Let's look at this one also. So this is 4 to the power root x equals 16. Okay, now let's change this one to a base of 4 with a certain power. So 4 to the power root x becomes 4 to the power 2 because 4 to the power 2 is 16. Okay, now we can equate the powers straight away. So let's say root x is now equal to 2. Then we need to find x. So what do? When we have root of a variable, we put the square. This is square root, so we put square on both sides, or we raise both sides to a power of 2. So this is going to be a power of 2, another power of 2. So this will take care of this one. Then x becomes 4 because 2 to the power 2 is 4. So the answer is 4. Okay, let's look at this also. So this is having a base of 3 and then a power of 2x minus 2 equal to 9 having a power of 2. So let's try to change this 9 to a base of 3 with a certain power. So 3 to the power 2x minus 2 equals 3 to the power 2. That is, this is going to give you 9. Then with this 2 also here. So 3 to the power 2x minus 2 becomes 3 to the power 4. Because this is the third law. Okay, so I can equate the power because the base are the same. So 2x minus 2 becomes 4. And then 2x is going to be 4 plus 2. So 2x will become 6. And then we divide both sides by 2. And x becomes 3. Okay, now let's look at this example. So you can pause and then solve this one after. Then you check to see whether what I'm going to get is the same as you also get. Okay, now let's see. So this is 2 to the power 2 into brackets x minus 3 equal to 1. Now because this 2 and this 1 are not the same, but we can still change this one to a certain 2 with a certain power. So we can say that this is 2 to the power 2 into brackets x minus 3 equals 2 to the power 0, because we said any number to the power 0 is 1. So 2 to the power 0 is the same as 1. Now the base are the same, so we can equate powers. So 2 into brackets x minus 3 becomes 0. Then we expand this. So 2x minus 6, that is 2 times this is 2x, 2 times this is negative 6 equals 0. So 2x becomes 6. Then we divide both sides by 2 to get x to be 3. Okay, please try this example on your own and then let me have the answer on the comment section. We'll meet in the next lesson. Bye. Please do not forget to subscribe, like and share the channel. The name has always been Odum Maths. On TikTok it is odum.maths. Bye.